And my name is Carrie O'Neill, and I'm excited to have Mr. Murray here to give us an idea of what it's like being an electrician and what the opportunities are. So, Jimmy, you can go ahead and take it away, sir.
All righty, well, let's get started. So, as my mug right there, as was said just a moment ago, my name is Jimmy Murray. I am a Barstow local. I graduated class of '09 from Barstow High School, and I got my AA from Barstow Community College in 2011. And I went into the military, United States Coast Guard, and I was in the Coast Guard for 6 years. And that's where I actually found out that I really enjoy doing electrical work. So I started on my first boat is when I started doing mechanical type work. And that was around 2013 is when I got orders out to Oxnard. So right there, here in Southern California, not too far away. And we got underway, and that's when I really decided that I like the hands-on technical aspect. And so from there, I was able to start shadowing machinists, welders, and electricians. But for me, what really stuck out was the electrical work. So I put in my package for electrician school. So I went into Yorktown, Virginia, and I did 6 months of technical training over there at Training Center Yorktown for electrical school. And then I got orders to Texas as an electrician, where I spent the last part of my career. And once I separated there, I got hired on with GE Power as an industrial maintenance electrician. And I worked there for over a year. And once I was working there, my wife had been really wanting to come back here to Barstow. And we heard the railroad was hiring for electricians. So that's what brought me back out here, was BNSF Railway. And I've been here at BNSF for a little over 2 years now. So that's kind of just a quick background on where I am, where I've been. So what do electricians do exactly? Well, we do a lot, but mainly we design, install, troubleshoot, and maintain electrical equipment. So on this slide right here, you can see this is actually stuff that I worked on at my last job with GE Power. So very large industrial size motors. Over here in the middle, we have, it's called a terminal board. And each one of those little pieces, terminal blocks, just wire terminations. So it makes it easier for troubleshooting purposes. And then here on the right is a panel I actually built myself for our customer. So continuing on what we do, bread and butter, we really have to be able to read and interpret electrical diagrams, known as schematics. So the one on the left that we have here is called a line diagram, which gives you a very big general picture of like what's going on, main systems. And on the right, we have what's called a wire diagram, which is a very in-depth, and as the name would imply, wire by wire indication of how a circuit works. So you'll have to be able to take those two schematics and turn them into this. So from the schematic, the schematic itself was, I know it was probably kind of small and you couldn't see it, but that was for the motoring and braking capabilities on locomotives. And then these are the components that we actually would have to troubleshoot and service to find the problems. And I don't know if you guys can see it, but on the picture on the right, I circled some of the locations where where the equipment would be located on a locomotive. So as you can see, like you would have to be all over the place trying to find out where that problem is. So that's why the schematic helps. It gives you that idea of what it is and how it works. So that way you don't have to be running all over chasing your tail, trying to figure out what you're doing. But if you didn't work for the railroad, electricians, we're basically everywhere. And you can see from some of these pictures, on the left, we have a high voltage wireman. So if you ever want to go to lineman school, that's the kind of work you'd be doing. On the bottom, that's substations. So if you want to do any kind of power distribution, keeping it relevant to current times right now, I know in Texas, they're having large power outages. So those guys right now, they're probably getting a lot of work just trying to put Texas back and give them power again, because a lot of their green power is getting knocked out by the cold temperatures. And then on the right, there's just looks like some type of low voltage digital, wiring for a security system, perhaps. So you're going to have to be able to utilize hand tools and working with your hands, have a good type of mechanical aptitude as an electrician. So this right here is my backpack that I carry every day. This is probably what I use for about 90% of the time. Plus we have specialized tools that we can check out from our BNSF stock tool room. But for the most part, screwdrivers, wrenches, adjustable wrenches. Down here, we have a little pry bar because sometimes we'll have to pry open large cabinets and lockers, ratchets, 1/4-inch drive, 3/8 drive. I brought in some gear wrenches to kind of help make my job easier, zip ties, channel locks, wire strippers, wire cutter.
What are you using the zip ties for?
I could show you guys in a couple pictures later, but essentially on locomotives, we have lots of large cables and even small cables really that are running all over inside the locomotive. And so you don't want those things hanging down freely. You know, somebody could walk into them, pull on them, mess with them. So you always want to make sure that all your wiring is done nice and clean and you keep everything in like one tight spot. And it prevents, like I said, problems from people pulling on stuff, coming into contact with energized wires.
Mhm.
So
Awesome.
it's mainly just aesthetic as well as safety.
Right. So I don't see any electronic tools. Are there any other electronic tools that electrician might use?
Yes, the biggest one that we would use, I think I have it in a picture later, is our digital multimeter.
Okay.
And that's going to tell you lots of things that you need to know about electrical circuits, like what kind of voltage they're producing, if they're actually electrically hot. If you want to do a no voltage check, you can set it to resistance readings and you can actually check to see if like a wire is broken by using the resistance setting. We also use, it's called a megometer. It measures like very, very high amounts of resistances, like for motors. We have to check those out. Those are very expensive tools. And then we also have kind of like the opposite of that. It's called a micro ohm meter. And those are also very expensive and they can tell you to the is a very, very finite amount how much resistance something has.
All right. Thanks for
So
those
yeah,
questions.
those aren't pictured, but we do have those in our tool room for to check out for whenever we need them.
Awesome. Thank you for answering those
Oh yeah, no
questions.
worries. So here's a picture on the right. So that's why you would need to keep tie wraps in your bag, because you want to keep all the cabling like that, you know, nice and tucked away. That's all high voltage. So when the locomotive is actually steaming down the road, a lot of that will be picked up and electrically hot. So you just want to make sure that you keep everything in there and, you know, nice and clean. And then over here on the left, we actually have an alternator that would go inside the locomotive. So locomotives are similar to cars, but they're also very different in the sense that, you know, on a car, you have a very small alternator that basically just recharges the battery. On a locomotive, the alternator is the powerhouse for that unit. On the bottom, they're large motors instead of actual wheels. So this is what provides the power to those motors. And then it also provides the power for basically every other electrical system on the locomotive, as well as recharges the starting batteries, which are, and like a typical day for us, basically anything that you would see inside the operator's cab that has any type of electricity going to it, we will fix. We'll service it, replace it, troubleshoot it, anything that you can think in that cab. Over here, I've probably taken out and messed with at some point because it was defective. And then over on the left is actually a specialized job at the railroad. It's called PTC, and that stands for Positive Train Control. And the main reason this was implemented was for safety. There was a railway accident a while back with Union Pacific Railway. One of their operators had not paid attention to the signal to slow down, and he wound up running through a locomotive switch and colliding with a passenger vehicle, an Amtrak train. And when that happened, I think around 70 people died. So in order to prevent accidents like that from happening again, we installed the positive train control where somebody could actually remotely tell the locomotive to slow down. Like if they're going through a certain speed limit and it's been reduced and they're still driving way too fast, they can initiate penalties against them and cause the braking to actually pick up remotely to slow the locomotive down to prevent any loss of life or injury.
Jimmy, before
So
you move on, I just want to talk about this particular picture. You said it's the cab, so this is not necessarily where you would sit and work on a daily basis, but you're repairing all the electrical stuff there, right?
yes, so depending on what we're doing with the locomotive, we have different steps. Like we have our inbound procedures where we have to just do a quick visual of the entire locomotive before it gets either sent back out to the main line because it was found no defects, or if it gets sent to the shop. So if it's in the shop, we could honestly be working on anything in here or anywhere else on that locomotive that has electrical components. It could be under the locomotive. Sometimes we have to get height, like harnesses, to work on top of the locomotive. We'll go around the backside of the locomotive. I mean, pretty much anywhere that we have any kind of lights or electrical components, where we will be responsible to work for it.
Right, right. So what are the positions of the people that actually operate the train or work in the cab area? Like,
Well, they're actually hired with a different department. It's all part of the same penumbra. It's all BNSF Railway, but we have different departments. So where I work is locomotive maintenance, LMIT,
mhm.
but they also have an operations department, and that's who will actually be driving these down the main line. So they have engineers, which are the ones who will drive the locomotive, and then they have conductors, which are actually conducting the train operation. So they'll be talking on the radio, trying to figure out the plan of where to go, when to stop for fuel, where they, if it's heading east or west, what they're doing with it. So they'll have a crew of two. Sometimes they'll have more if they want them to rotate through, if they're going to a spot where they'll have to swap crews. So that is a different department, but they do work out of the same facility. Over here on the left, how we were talking about earlier, the electrical multimeter, the digital multimeter. There's a snap of me using one right there to shoot down that component that's in my hand. That particular component helps keep the locomotive cool by opening and closing big fans on the back of it. And they shopped this particular locomotive because it was overheating and causing the engine horsepower to derate. So they weren't getting the maximum pulling power for it that they wanted to. And that's where I found the cause of that problem is it wasn't opening those fans to cool it properly. In the middle, that's more switch gear that will tell like the locomotive, hey, like, do you want to go forward? Do you want to go backwards? Do you want to be motoring, or do you want to actually be trying to go into braking? And one of the contactors in there was actually blown up, so it wouldn't switch from motoring the unit to drive it around to the braking side of it. And then over on the right, we have a picture of a speed sensor that was cut off, and they were trying to figure out why they weren't getting RPMs for this particular device. And it's kind of hard to get RPMs for something when it's not there. And so over here, this is something like you would see coming through our yard for major repairs. I was informed that there's a lot of students here that have a mechanical type background. So this is where the two crafts at BNSF Railway, electrician and machinist, will kind of work together. And over here on the left, you see my cursor, that was where the turbo for the engine was. It wound up exploding. It had I think it had either a locked axle or it lost lubricating oil, and it wound up catching on fire. So that wound up destroying this whole back half of this engine, the inlet manifold for it, and all the electrical sensors for everything that was back there. So we spent a good while on that, getting a parts inventory and rebuilding it. And we wound up releasing that one, I think, about a month and a half later. And then over here on the right, it looks like another engine change out. And so they have the top part of this locomotive that's pulled up so that way they can actually lift this engine out and take it out. And then here's more pictures of the just stuff that we've fixed here at our yard. This spot over here on the left is actually the place where you would fit this component on the right. So those are pretty massive motors. I mean, they weigh probably about 1,500 pounds, if not more. And we actually have to use lifting cranes that we have on site to pick those up and put them in. And you can see on the picture on the left right here, there's some chains hanging down. So those are the chains that we were using to pull the old motor right here and then put the new one in. And then this over here, these little terminals, as I was saying earlier, the wheels on the locomotive are electric. There's no drive shaft down there that runs the length of the locomotive like on a car. So these wires will actually hook up to big cables on the underside of the locomotive. And they're what tell the locomotive to either go forwards, go backwards, or to use as a feature, it's called dynamic braking, but that's what slows the locomotive down. If we were to use brake pads like on a car, they would burn up within minutes. It wouldn't even be close to efficient. So we actually use a process called dynamic braking to slow the locomotives down. And in order to do all that, we have these little carbon brushes right here, which provide an electrical connection inside this motor. And so we have to change those out from time to time. This one right here is a new motor or a new brush. And this one right here is an old one. So they wear down over time. It's normal. And then this picture on the right is how everything will look when it's been properly serviced and it's brand new. And if it's not done properly or we have any type of problems, you'll see this. This is what's called a locomotive traction motor flashover. So obviously it got really, really hot in there, caused everything in here to overheat. This is insulation from inside the motor. You can see it's all caked on there. It's that nice tin color. And in the middle over here, we actually had one where the brush got so short. Remember, like in that picture, they wear down. This one in the middle had gotten so short, it actually wound up exploding. And it caused everything else in here to actually flash over too. And same with over here. Just got so short, it broke into pieces. Caused this whole motor to go bad. Okay, so I thought instead of talking the whole time, what would actually make this a little bit more interesting and more fun would be to just do like a little interact. And I put some bugs in it. And so I thought it might be more fun instead of just hearing me talk. Okay, so I'll come over here now. And basically what we've got here is just a very simple circuit. Like you would see, I actually modeled this one after the plant that I worked in. And basically what was happening was, well, we would receive certain types of chemicals that we would have to process and filter through our water process technology plant. And so what we ended up having to do is if the system got too overloaded, we had what was called a boost pump that one of our operators would be able to turn on in order to assist with the extra flow of chemicals and then turn it off. So that way later we wouldn't be overflowing our system. So what they would do is really simple. Just turn the switch on. It would have a warning light that would kick on, and then it would cause our motor to spin. It would help push the chemical through. And once we were done, like, okay, we're done with the bulk of it. We can just use our regular system. So we have our first scenario here. It says the motor is not turning on after maintenance was performed on the batteries. So as you can see, we go to our switch here. Oh no, nothing's turning on. Our warning light's not coming on. Our motor's not spinning. What do we think could have possibly happened here? Okay, so I actually have this here. This right here is called a test light. You can actually check for voltage on this circuit. So does anyone want to think of a spot where that perhaps you might want to check for voltage? We know the on switch isn't turning on.
Looks like the batteries need to be switched.
Yeah,
What do you
they
guys think?
put the battery in backwards. So kind of as like a quick reminder, that's always an important thing to double check if you're following up after somebody, is you always have to double check the work that's been done. So if you knew it was working before, someone had messed with a certain component and now it's not working, odds are it's probably that component. So in this case, it actually was someone put the battery in backwards after they did the maintenance. So now switch the battery around, now it's working again.
All right.
Okay. Now, same thing over here. You get told by the plant operator that he went to go turn on the boost pump, and it's not turning on. The main difference on this one is last time we would turn our on switch on, nothing was coming on. This time, we know we're getting voltage at least to here. So if we know we have power to this side and power to this side, and it's a straight shot from here to the motor, what could that possibly mean? We have power making it all the way through our switch to the other side of our switch, down to where the motor connects, all the way over to where it should be hitting, and it's not spinning. So this motor's bad. So that's basically what troubleshooting is as an electrician, is using an educated guess, knowing all like what maintenance has been done and what needs to be done, and knowing what outcome you have and what you need in order for it to work again. And what's interesting is some of the classes that we take in Kansas City and here in Barstow, that's honestly basically, exactly what we're doing, is we're going through and they have a simulated computer just like that, and they'll have us walk through like, oh, well, this motor isn't turning on, or our warning light feature isn't coming on, the safety feature isn't working, what's wrong with it? And then you would have to work through it that way, knowing how the circuit works, knowing that there's a problem, and being able to work your way back and figure out so that just touches on what I'm talking about right here, for tool use and terminology, and knowing that you'll have to use certain tools and certain equipment in order to test what you're working on. Problem solving, it's just a big puzzle, really. Being able to look at each piece of it and being able to know, well, if I have power here and I don't have it here, what could possibly be going on in between. Okay. And then lastly, a little bit of computer knowledge, especially working here at the locomotive or at BNSF Railway, is going to take you a lot further, because we actually use computers to help us diagnose what is wrong with these locomotives. So if you were considering a career in the electrical field, this is kind of like a good way for how to prepare for it. So like the number one thing would be to actually have an interest in the job. Nobody wants to go to a 9 to 5 that they really can't stand where they're at, especially in a career field where if you're not paying attention, you could actually kill yourself. So you really want to be interested in the job, and then have a desire to want to learn more and grow in the field. If you're just starting out, it's a good idea to get into any type of program that you can, like whether it be at the high school level or the collegiate level. And hopefully they'll teach you how to use basic hand tools, basic terminology, basic safety. Safety is super important when you're in a field like this, where if you touch a live wire, I mean, you could send yourself to the hospital at a minimum, or you could sustain serious injury if you're not doing it right. So again, if there's any kind of college classes, If you want to do a union apprenticeship, if you would rather not go to college at all, there are options to go and get an apprenticeship through a local union, or you can do like how I started out and just go into the service, and then they will teach you how to do troubleshooting and maintenance that way. So some of the benefits of being an electrician or any type of skilled career, whether it be machinist, maintenance, welding, what have you, you are part of a skilled trade. So that's something that can never be taken away from you. So even if you decide that, you don't want to do electrical work all your life, 10 years down the road, if something happens in your house where you say you want to install a new outlet or just something basic for your car, you need to change out the battery. It's something that you're always going to know how to do, and it's something you can always fall back on. In turn, that gives you good job stability, knowing that, say, if I left the railroad, I could go find a job either with another railroad that's not BNSF. I could go into any type of trade, industrial type deal, do electrical work there. I can do commercial electrical. I get everything. It all plays together. So in that respect, it's always good for job stability, knowing that you can leave one job and go to a related job in a similar field because you have that knowledge. Specifically to the railroad, we do have great health insurance here, and there is good retirement package here too. So if you're playing the long game, which is kind of how you want to try to play things, I mean, you go into with the railroad is really a great option for the long game. I think the part of my job that I like the most is getting onto a locomotive that there have been people that they haven't been able to figure out what's wrong with it for multiple shifts. And you're the one that comes in and says, oh yeah, I found out what's wrong with it, and this is why. And you're able to get that thing out of there. I've done that a couple times. And I think that's probably what gives me the most satisfaction, is knowing that I was able to fix something. And from where I live, I can actually look out of my window and I can see, the rail yard and how close it is.
Mhm.
And there's been a couple of times where I've seen a locomotive that I was on the night before pulling freight the next day. So I think
Awesome.
that's actually pretty cool to be able to know that you're having that type of impact on the business, that, hey, something that was literally broken and torn apart 8 hours ago is now pulling, someone's Christmas packages, someone's Amazon delivery, so, whatever it is, whatever kind of freight that's going down the road that day, that, that unit's going to be pulling it.
Awesome. I have one more question. A little ways back in your presentation, you talked about working with the mechanical side. So that got me thinking about, like, do you work on your own throughout the day, or do you have a partner that you work with, or how
Oh,
does
okay.
that work for you?
It honestly depends on the type of work that you're doing. Ultimately, there are some jobs that you need to have a second person with you. For instance, if you're going on top of the locomotive, you need to have a partner with you because you'll have your fall harness on. You're on top of the locomotive. If you fall off and you're dangling in the air, you would want somebody to be able to help lower you down. So jobs like that, it's a mandatory 2-person job. Usually they'll put you with another electrician because you guys will both have an idea of what needs to be done and how to do it the most efficient and safe way.
Mhm.
But every night they will always put one electrician and one machinist on a locomotive at a minimum, if there's work required for both. So I actually work, I would say, the most with other machinists with the other craft. And then depending on the type of job it is electrically, they might give me an electrical partner, they might. So if something like BNSF Railway interested you and you were thinking of applying there and you were curious about like what the application is, and this honestly goes for machinists as well as electricians to an extent. This is kind of like a quick breakdown. They want you to have at least a high school diploma. For work experience, if you're coming in as an apprentice level, they don't expect you to really know anything. They see it as you're coming there to learn, and they'll give you the education and the training that you need in order to perform the job safely and efficiently. But if you're trying to come in at journeyman's wages, which is like the most that you can make there, they want you to have at least 3 years of qualified electrical work, and you would need to have supporting documentation to prove that you had that job. So for me, when I got hired, I took in my military DD 214, which is the paper they give us when we separate. and it had duty stations and titles that I held throughout my military career. So they were able to verify that from 2013 to 2020, I was actually doing electrical work and maintenance type work. And I also took my contract from my industrial job. So they were able to verify that I was actually working there. For salary, apprentices, if you get hired on with no work experience whatsoever, they'll pay you 80% of a journeyman's wage. And each year they'll advance it 5% till you hit your full 100 at your 4th year. And the pay is right now we currently make $33.13 as an electrical journeyman. But depending on how the union structures their agreement with BNSF, that's called our collective bargaining agreement, our pay will and our benefits will vary. So every few years, they'll negotiate a pay raise or they'll negotiate a change to our benefits package. So really it just depends on where the union and where the company come to an agreement. It will determine our pay and our benefits. But we do know for sure that apprentices in their first year will make 80% pay that first year, and it will work up to 100% by their 4th year. So to apply, you would just go to jobs.bnsf.com. Yeah, they do have minimum qualifications. So like when you get hired on, they will do a hair follicle test as part of a drug test. So on that, in California, it actually is legal to utilize THC for recreational purposes. But as far as the railroad is concerned, we follow federal guidelines. So we actually, if we have any type of THC in our system, we can be terminated from employment. So it's always something to consider when picking a job like this, is you kind of have to know like what's acceptable and what's not. They'll also have you take an aptitude test as well as your hair follicle. And they basically want to make sure that you have some common sense. Like the aptitude test isn't anything particularly crazy, but they just want to make sure that like you're not going to do something so outlandishly like bad in a shop environment that you're going to get yourself hurt. So once you do your hair follicle screen, your interview, and your aptitude test, they'll begin like a formal interview and hiring process. And you'll come here to Barstow, actually do a formal interview with the shop foreman, and they'll ask you about your experience, how you heard about the job, why you want to come and work here. And if everything goes great on that respect, they'll actually offer you a job. And they give you a 120-day probationary period from the company to where like you can't mess up. Like they want to see that you're there to learn and you're there to work. And then the union, when you got hired on, you're a union employee. For us, it's the IBEW, the International Brotherhood of Electrical Workers. We become a member of the IBEW, and if you're a machinist, you join it's like International Machinists Union, I believe is what they have. And from there, you have up to 90 days to begin paying your union dues. And if the union determines that like you're incompetent, that they will actually rescind your position. And then the company will have to let you go because they hire union. Once you make it through all the hiring process, all the legal mumbo jumbo, signing the paperwork, they'll start you off day one, and you'll have a 4-year apprenticeship if you become an electrician. If you're a machinist, it's a 3-year apprenticeship. So for electricians, we basically, in order to become a fully qualified journeyman, you have to pass the level 1 journeyman's exam. So if you can see on the PowerPoint, I kind of have an asterisk there. When I got hired, I was hired on as a full journeyman, and I basically was, I had a 6-month window where I passed my test, and I came out of my apprenticeship 3.5 years early because I didn't necessarily need the same training and troubleshooting and things like that some of the other people who hadn't been electricians before would know. So I was able to become a journeyman much sooner. But you have up to 4 years to use that time to learn how to be an electrician. and then pass your level 1 exam. And once you pass your exam, they will do an additional test. It's called a walk around. And the technical training coordinator for the electricians will come out to a locomotive, give you a schematic, and he'll put little bugs on there, kind of like how I had for that little project we did earlier. And he'll say, okay, this is what the problem is. I need you to figure out why. And as long as you can find all the little bugs that he puts in there, they'll give you your level 1 certification, and you're good to start working as a standalone journeyman. And once you become level 1, there are options to keep going in your career. And we do currently have a level 2 journeyman's position, and I'm actually currently working towards getting my level 2 certification.
I have a couple questions. You mentioned
Okay.
that there's the journeyman's exam. Is that given by BNSF, or do you have to go out for that to
Yes,
take
it's
the exam?
actually given by the company,
Okay.
and you have to go seek out the training coordinator, and he will pencil in a time for you to show up to his office. And they have a computer that you use specifically for the test in order to keep it from getting compromised. And so you log in, he gives you the computer and some scratch paper, and he lets you take the exam. The level 1 exam is 100 questions, multiple choice, and you need an 80% or higher to pass.
Now, is there, like, if you did not get the 80%, is there a certain time period that you have to wait before you can take it again, or?
Yes, if you take the test your first time and you don't get the minimum qualifying score of 80%, you have a 3-month window where you have to wait 3 months in order to retest. Once you take your second attempt, and should you not pass it on your second attempt, you have to wait 6 months. And then that becomes the new standard. Every 6 months you can attempt to take the test.
Okay, all right.
So doing a little bit of quick math, you can see that if you have a 4-year apprenticeship and you wait till the last minute to try to pass your exam, and you don't give yourself at least a year or 2 to test, that could come up and catch you real
Mhm.
quick.
The other question I have is, the apprentice, if the apprentice is working, do they get partnered with the journeyman electrician throughout the day?
Y- Yes, per our company's policy, a an apprentice should always have a journeyman assigned to them. So depending on how comfortable the apprentice is working on their own, they don't necessarily have to be on the same locomotive as the journeyman, but they will always be able to reference a journeyman like, hey, this is the problem I'm having, and I can't figure it out. Maybe you could help me a little bit. So I know for me, like when I came here, they started to trust me to be able to work on my own, not need supervision, oversight.
Mhm.
So I had been there for like about 5 months at that time, and they would actually assign me to my own unit, just like they would to journeyman. But they would say, okay, we want you to work this unit by yourself, but if you run into any problems or you need help, this is your assigned journeyman for the day. Go find him, and if you have any questions or problems, you can seek him out for help. So they'll
Okay,
always have at least some type of reference there for you in order to have a qualified person instructing you and helping you along
got
the way.
you. Okay, good to know. There sounds like there with apprentice, there's going to be a lot of training involved. So
Mhm.
what type of training program do they have at BNSF for the apprentice besides having that mentor?
The biggest thing that they have is we do have classes that are required for apprentices to take. So we have like a basic troubleshooting, locomotive basics, and then we obviously work on multiple kinds of locomotives here. So there are training classes for each type and each style of locomotive. So that way you have an idea of how to troubleshoot each one. There's 2 main manufacturers of locomotives. One is GE, and the other is a company called EMD, as a electromotive diesel. They're owned by the GM, General Motors Company. So depending on who manufactures the locomotive, they're drastically different. GEs and EMDs, those are the big brands. So you actually find some guys that prefer working on one brand versus another. They're more comfortable and more knowledgeable because they are different. So depending on, the locomotive they put you on for the night, one night it could be an EMD brand SD70 Mac. And then the next night they'll turn around and put you on a GE brand Dash 9. So you would have to be able to know how to work on both of those competently and
Are there opportunities to move around in the company or up?
right now with the economy being as it is and with coronavirus impacting things, it's a little bit harder, but there are opportunities, or at least there were before, to be able to put in for a transfer. So you could actually uh, move to another position within the company, and I believe they would give you preference, say as like if they offered the position, to all people, like say if they wanted to hire from the street, but if you wanted to transfer to that position, you would gain preference over somebody that they're hiring.
Really appreciate your time that you've taken to be with us here today.